Okay, we're going to pick up where we left off last time on number 22. We were saying that if you use the standard rule about is it positive or is it negative for tangent of 165, 165 is located in quadrant 2. Tangent is negative in quadrant 2. So if you are using your option, because remember you have 3 options for half angles for tangent. There is one that looks like this. So if you so choose to use this one, and in all honesty, I normally don't use it, but I'm going to use it just to prove a point. Okay, if you choose this one, you have to go through all of this. Which one do you want? Do you want the positive or do you want the negative? That has to be done. There's no way around it. In all honesty, I would never pick this one. I'd do one of the basic ones where it was either sine A over 1 plus cosine A, or I'd do 1 minus cosine A over sine A. And because this one over here is just kind of crazy compared to the other two. But if you choose this one, you have to choose the negative version. Okay? Now, you're trying to make this 165. So if you're going to make that 165, basically you have to double the top number. So 165 times 2 is, let's see here, that is 330. So 330 divided by 2 is 165. So that's gonna work just fine. So now over here in my formula, I can put 330 in the place of A. I just need to maintain a negative here. Quite honestly, this may end up being a hot mess, because I think these other two over here on the right would be much simpler and much easier to use. But hey, let's see where it goes. We got 1 minus cosine 330, and then we got 1 plus cosine 330. All right, we obviously need a picture. So 330, fourth quadrant, 30-degree reference angle, -1, 2, square root of 3. Okay? So, it's fixing to get pretty messy here. Cosine of our diagram is square root of 3 over 2. Both places, square root of 3 over 2. If you come through here and clear everything, oh, and by the way, I've got it, we don't need to lose our negative now, do we? That's going to be 2 minus square root of 3 over 2 plus square root of 3. All right, that obviously does not match anything that we have. You see what I'm saying? This is nasty, 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 nasty. This is why I wouldn't pick this one. So, in all honesty, I want to bail on it and use a different one and just show you how nice it is to use one of these with easier structure. I mean, we could keep working with this, but why in God's name would you want to? Let's just pick up with one that looks kind of like it's structured more easily. Let's use this bottom one here. It's going to be tangent of 330 over 2, and then we're going to have 1 minus cosine 330 over sine 330. Now let me scoop this up so we can actually see what we're doing. There we go. Got a little bit of room. All right, now you can still see our picture. Cosine of that picture is square root of 3 over 2. Sine of this picture is -1/2. Now see, that didn't look nearly as bad as that other thing we had. That was just a nasty mess. Okay, 2 over 2. Distribute that. 2 minus square root of 3. And then down here at the bottom, the 2's cancel and you just get -1. Well, all that -1 is going to do is like you're distributing a -1, so change your signs. Remember out front here, lovely -1, that's what you're getting. So, we need to find, oops, that wasn't a 2, a 1, that was a 2, wasn't it? -2 plus square root of 3. See, that was a lot simpler than that other problem. -2 plus square root of 3. C. Okay, now, for those of you that haven't been through this yet, number 23, 24, and 25, I want you to exit those. We're going to go to number 26 and work through that one. We have got the square root of 1 plus cosine of 20 over 2. And it says to identify and write the expression as a single trig function or as a single number. Okay? Basically, you need to pull out your note card and you need to identify which one of those that is. Basically, just start looking. Obviously, you need one that matches square roots. The only one that has 1 plus cosine is cosine A over 2. Now keep in mind this right here is A. So if you do that, that's going to be cosine of 20 over 2. Cosine of 10. Now you can't evaluate cosine of 10. That's why they left it like that. There's your answer. Alright, we're going to, something is a little weird with 27. In all honesty, I just couldn't figure it out, so I just deleted it. So I'll put a big X on 27 for right now. All right, 28, same instructions. Find the match. I've got 1 minus cosine of an angle over 2. That right there, 1 minus cosine of 14 theta. That's not 140. When I first looked at it, I thought it was 140. It's not. It's 14 theta. That matches sine A over 2. So remember, A is right here. So you're going to have sine 14 theta over 2. So that is sine of 7 theta. So there's your match. You can't do anything else with it. Okay. Now at that point you swap. It swaps to section 6.1. So the inverse trig functions. This is that last thing we did. Half of them are going to be with radians, half of them are going to be with degrees. So you've got to be ready to think about where do these angles occur. You also need to remember your stuff about your restrictions. If you have a positive value, all trig functions are in quadrant 1. If it's negative, some of them are in quad 2, some of them are in quad 4, we're never going into quad 3. So let's just think. If sine, his reciprocal, or tangent is negative, you got to go to quad 4. If you got cosine, secant, or cotangent, and they're negative, they go in quad 2. Now, what we had done in the past, and this didn't dawn on me until yesterday, sorry, we've always taken reciprocals. So if I give you secant, we take reciprocals. If I give you cosecant, we take the reciprocal. That will work just fine with sine and cosecant, and that will work just fine with secant and cosine. It will not work with tangent and cotangent, because if you take the reciprocal of cotangent, it changes the quadrant you go to. So you cannot take the reciprocal of cotangent. You will end up in the wrong quadrant. So if you were given cotangent, you have to draw it and label it, and just instead of doing opposite over adjacent, do adjacent over opposite. So just heads up, that's what you got to look for. So let's get started. Number 29. Where does sine have a value of positive square root of 3 over 2? It's positive, so first quadrant, opposite, hypotenuse. Now what is that angle measurement? That angle would be 60. What's the radian for 60? Because these answers are in radians. That would be pi over 3. That's option A. Okay. I X'd this one out because we had the issues with the cotangent thing. I'm going to keep it X'd out, but just for the sake of discussion, this is the one where you can't take the reciprocal of it, because the reciprocal of cotangent takes you to another quadrant. It's like you're going to the wrong dimension. You can't do that. So cotangent has to be over here. Cotangent is -1 over 1. Alright, that's still going to be a 45-degree reference angle, but he's in quadrant 2, which puts him as 135 degrees. If you want to convert that, or you're thinking, hey, that's pi over 4, subtract him from pi, that's going to be 3 pi over 4. this would be the appropriate answer there. Okay, arc tangent, remember that just means the same thing as inverse tangent. Where does tangent have a value of positive 1? First quadrant, that's still going to be 45 degrees. 45 degrees is pi over 4. Again, arc sine is the same thing as inverse sine. That's positive, so first quadrant, opposite, hypotenuse, other side, that is 30 degrees. The radian for 30 degrees is pi over 6. Here we go again. Tangent, it's positive. First quadrant, square root of 3 over 1. Well, I didn't draw that according to scale, did I? But the point is that's 60 degrees. 60 degrees correlates to pi over 3. Now, this, at least now you don't have to swap them anymore. It says give me the degrees. Now, it's secant. Secant, his reciprocal, remember he's in the same quadrant. So if you want to flip that one, it's okay. Because remember what we said, secant goes with cosine. So secant and cosine and cotangent are all negative over here in quad 2. So it's okay to do reciprocals of these two. They live in the same dimension. Over there in the same quadrant. So if you want to think, hey, let's take secant and let's kind of flip him out and make that cosine and let's do the reciprocal. It's going to work. It'll be fine. But that's not even negative, is it? I did all that and it's not even negative. It's positive. So it really doesn't matter, does it? Okay. So let's see here. Opposite is 1, square root of 2 there. So again, 45. Y'all should be good with 45s. We are in first quadrant since that thing is positive. So that would be 45 degrees. Go to the next one. Cosine. Cosine is, that's going to be same thing, right? 1 square root of 2. It's just been rationalized. The answer just is in a different form. 45 degrees because it was positive. This is one of those where you have to work a little bit further. Got to do the inside part. Now, that one got a little dark. I don't know if y'all can see that or not. You got to do this part first. Draw the picture. So come in here, and it is positive. That's 2 over 1, right? So 2, 1. You've got to figure that out. So good old Pythagorean theorem. X squared equals 2 squared plus 1 squared. 4 plus 1, so x is square root of 5. Okay, right? So square root of 5 right there. Once you get this, what is sine of this picture? Opposite over hypotenuse. So 2 over square root of 5. But you know you can't leave it that way. So fix it. 2 square roots of 5 over 5. C. All right. I told y'all that I would delete this one just because it does go into double angle formulas and stuff. I don't think we need to get that complicated. This is on the final exam review, so let's walk through it. We've done the same problem in class. Let's try to do it so it fits on this video. You have to determine where tangent is u. That is u over 1. u1. Pythagorean theorem. Let's do this quickly. That is x squared equals u squared plus 1 squared. U squared plus 1 is x squared. Do the square root. That's your missing side. As nasty as it is, that's it. U squared plus 1. Now do sine of that picture. Sine of that picture is opposite over hypotenuse. You've got to rationalize it. Rationalize like normal, even though your radical is like stupid weird. You've got to rationalize. That's your answer. Go fishing for him. There he is. Should be good. Good luck, guys. Study up.